Hi, and welcome to another 5-minute tutorials in Unity. This week we'll be continuing from last week and adding the ability to throw objects. So we'll be starting with the project we have last week. I'll include the download links for both last week's project and this week's project. Corey just wants to demo what we've got at the minute. So we can pick up objects, but we cannot throw them. They're useless, really. So if we open up the object pickup code, first things first, we need to add a boolean so that we know when it should be being thrown. So we can add a private bool, just call it throwing will do. We also need to go and change down here. So here we go throwing is equal to true, so we know that it's being thrown, and we also want to set it to be false when we pick it up so that we're not accidentally doing anything we shouldn't be. Now we'll also need a reference to the rigid body of the thing we're holding so that we can add some forces to it to make sure that it moves once we've let go. Rigid body, and that needs to be set when just before we drop it, but before we set it to null. So we can go rigid body equals the joints connected body, like so, and we'll set it to null when we pick it up, I think. Because why not? Null. That's sort of the basic setup. The rest of the stuff that'll happen will happen in a fixed update because it's physics. So void update, fixed, yeah, update. So first things first, we need to know if it's actually being thrown. So we can say if we're throwing, do some magical code. Now to start with, we need a transform for the origin of where it's being held, sort of deal, origin. And we can say if the tracked object that we got earlier, if that's origin is not null, we can just use that as the origin. So we can say origin equals tracked object dot origin. Else we'll still need an origin, so we can just set the origin to be the parent of the tracked object. Tracked object dot transform dot parent. Once we have the origin, we can start adding forces, but just for a little bit of extra safety, we'll check that the origin's actually being set to something so that we don't have any problems here. Null, like so. And now we actually add some velocities to the rigid body. So of course this is the rigid body that we got the reference to when we let go, so it's the one we're throwing. And we start by setting the velocity. And we can do this by saying we need basically the controller's velocity, but we want it sort of in world space instead of local space. So we can go with our origin, we can use the transform vector to convert it from local space to object space. Controller dot, and we can just go controller dot velocity rather nicely. And in much the same way, we can set the angular velocity. So we can copy this down here. This will be angular velocity, and we want the controller's angular velocity. I do find, however, though, that this means that any light twists can send whatever you're throwing really spinny. So I like to times it by 0.25 so that it's there's less spin, but you can change that number if you want stuff to spin loads. Just add a quick else so that if the origin is null, a similar thing does still happen, but instead of using the origin in any sense, we'll just set it straight to be from the controller. It's not likely to happen, but just in case, we still get something. That's most of the code. It is just always good to set the max angular velocity so that nothing too crazy goes wild, and we can just set that to the rigid body's angular velocity's magnitude rather easily. And that should do it. Although actually, before I forget, we do need to then set throwing to be false, so that we're only doing it for one frame, and then at that point the inbuilt physics system will pick it up and continue to add velocities and make it fly. Now fingers crossed that should work. Not seeing any errors. So if Corey wants to try and pick up the cube, if he's done dancing, and throw it, like so. Isn't that amazing? We'll bring it back to him, and you can throw it, just like magic. Thanks for watching. Like us on Facebook, follow us on Twitter.